I'm Roland Geyer. I'm an assistant professor at the Bren School of Environmental Science and Management, which is housed at the University of California in Santa Barbara, or short UCSB. And I focus in my research on industrial ecology, life cycle assessment, and sustainable technology and operations management. Recent CO2 measurements show that since basically in the Industrial Revolution, CO2 levels have been on the rise, and they are now in 2008 are at 380 parts per million. In particular, I advocate the use of a method called life cycle assessment, or LCA for short. It's a very mature assessment methodology that looks at products or services from not just a point of use or the point of end of life, but its whole life cycle. In my research, I found that the most important life cycle stages as regards automotive materials and greenhouse gas emissions are material production, the use phase of the vehicle, and the recycling stage of the vehicle. A good example for that would be the electric vehicle, which many people call zero-emission vehicle, which of course relates to the fact that they don't have any tailpipe emissions. But of course there are, from a life cycle perspective, there are emissions, significant amounts of emissions related to the life cycle of an electric vehicle. It's just predominantly at the fuel production stage and not at the use phase of the vehicle. So really, technically, it should not be called a zero-emission vehicle. Let's talk about steel, for example. From a life cycle perspective, you have greenhouse gas emission savings at the use phase due to mass reduction potential because of advanced high-strength steel, without greenhouse gas burdens at the material production stage. At the same time, it's also just as recyclable as mild steel. So this could be called a no-regrets solution. There are no greenhouse gas emission trade-offs. Aluminum has mass reduction potential, but it comes at the cost of significantly higher greenhouse gas emissions on a per kilogram basis at the production stage, material production stage, relative to mild steel or advanced high-strength steel. Magnesium has a shown potential for vehicle mass reduction, but also life cycle assessments show that magnesium is a very greenhouse gas intensive material. Fiber reinforced composites have an additional challenge with which is the recycling of the material, especially thermoset polymers that are fiber reinforced are very notoriously difficult to recycle. Recycling can have a significant impact on the life cycle greenhouse gas emissions of a vehicle through displacing primary production further down the line. So if you're not able to recycle the material in a secondary high-value material, then you will not have this benefit. Life cycle assessment, I believe, is critical for the automotive industry to make sound and positive, overall positive choices in future vehicle design and material choice, also fuel choices, because there's a real danger that if you don't use a life cycle perspective, that you improve one aspect of the vehicle, but at the same time have increased emissions elsewhere, which might even outweigh the improvements that you engineered in the first place. Life cycle thinking basically warns us that the lightest material is not necessarily the material that achieves the lowest life cycle greenhouse gas emissions.